So we're having a conversation about whether and how we're going to try to dim the sun. There's many, many technologies. And I think Richard should talk to us a little bit about the document he sent to everyone, which was, if you don't mind me surmising it, was a description of at least 10, maybe 20 currently proposed aerosols that you would put in the atmosphere. Most of them from high up. In one example, from low, from the ocean up, and there's various particle types, and what ways they would be complicated, difficult, useless, problematic, fall out of the atmosphere too soon, et cetera, et cetera. And I think since Richard wrote something extensive, we should give him the floor and explain what he did.
Certainly, and welcome Dave Stutz for joining. Thank you.
Thank you, Dave.
Took me 10 minutes to find an email with the link.
Oh yeah, there was a single letter off in the link, and so it threw the whole link off.
Right.
Was that David?
Yeah, it's David.
Yeah.
For some
Yeah.
reason, he got screwed up. Go ahead.
As an aside, Dave, I want to talk to you about solar offline, and none of the phone numbers I have for you work anymore. And I asked Myron for your number, and he never got around to giving it to me. So
I'll send it to you.
yeah, okay, very good. All right, now since I was asked to speak, I'll talk a little bit about this paper I've written. So the basic idea here is fairly straightforward. We've got this kind of concept on the table about dimming solar radiance via changing Earth's albedo, which is the correct terminology to use. And the albedo is essentially the reflectiveness from an exterior point of view. For example, we look up at the moon and we see that, it reflects the solar radiance, pretty well. We can, a full moon and so forth. And different celestial bodies have different albedos. And Earth has a particular one that humanity has been altering through our, I'll call it inadvertent terraforming. Some people might prefer the word geoengineering, but we've been screwing up the place since the start of the Industrial Revolution. And now the idea is, can we use aerosols to help dim the solar radiance to give us, buy us a little bit of time? And the bottom line answer is a tiny bit. We might be able to accomplish as much as 3%, something like that, with a real concerted effort. And there are a lot of problems with it. And the document I wrote outlines the fundamental issues, of which there are a goodly handful. Most notably, just kind of in real summary form, the issues are, well, what materials should we loft? What will the environmental impacts of these materials be as they inevitably settle out of the atmosphere? What are the least harmful methods of lofting these materials? And given the difficulties of putting the material in the right amounts in the right places, how is it that we're going to be measuring what success looks like and make sure that we don't go astray? Then there's the question of, are there any extant distribution methods for spreading the particular types of materials that would be chosen? And on what time period would they need to be replenished, which has to do with effectively the rate at which they settle out, which is almost but not exactly related to their mass, the particulate mass. And that, of course, has a lot to do with particulate size. And then the final question is, given that lofting the wrong material or a mix of different materials might very well lead to an even worse disaster, we need a political decision-making plan. And I address that first by basically pointing to the United Nations, which has a fairly robust set of features already. And I propose ways to strengthen those political bodies in order to be competent at serving this potential purpose. Then I've got a section where I list 15 different potential aerosols to be lofted.
Richard, I can tell you, you don't have a screen that can do this. I have your document on the screen, and I'm trying to keep up with you. Keep going.
Oh, great. Yeah. Okay. Great. So I rank them by more or less the best mixing, or the mixing is not the best word to choose. At the top of 4, I talk about how they're ranked. They're ranked by the higher the ranking, high to low, by the overall effectiveness, factoring in environmental impact. So top of the list is calcium carbonate. And before I get into all of them, I'll just note that I've got at least one paragraph for each of a pro and a con, environmental impact, strategies for lofting, a conclusion, and then references to sources, you know, where I got the information, some of the better references available. And interestingly, some of the references that I use are in at least one of the videos that Myron has shared a link for us with. Then when I get into these, again, calcium carbonate, one of the great things about it is not only does it have strong light scattering and would help the albedo very much, it also neutralizes acidity by being mildly alkaline and would have minimal ozone impact. Some other choices have no ozone impact, which is also wonderful. The next one down is actually really probably my overall favorite, even though it's ranked number 2. Crushed basalt, basically into a fine ground silicate. It's chemically inert. It's geologically abundant. It reflects sunlight comparable with the best of them. Once it settles, for example, to the ocean surface, which is most of the surface of the planet, it can, first of all, form stable carbonate materials, permanently sequestering CO2, but also its dissolution releases calcium, magnesium, and iron, which can fertilize phytoplankton at the sea surface and thereby help feed the world's fisheries, and provide yet other biological CO2 drawdown pathways. Next is silica, which is basically just sand, chemically inert, low toxicity, moderate reflectivity. And then we start from here down. The choices are, in my view, much worse. Yes, they can be used, but they all have significant downsides, you know, from 4 on. The likelihoods of the wrong choice being made, you know, out of the 15 that are potentially, you know, more likely to be under discussion, 11 of them are bad choices. So, you know, some are worse than others. Y'all have the document. You can go through it yourselves. But the worst of them are probably diamond and sulfur dioxide, which rank similarly badly. The problems with diamond dust is that it will probably never really get a good chance to break down anywhere and will remain diamond dust and provide a micro abrasive that was going to have its own major problems, but also because of its incredibly small size, that it is almost certain to act as a catalyst in various ways and just cause all kinds of problems. Sulfur dioxide's worst downside is that it will almost immediately form a strong acid and cause all kinds of problems. And I'll remind you, those of us in the USA, we know about acid rain from the 70s and 80s, which was a horrifically bad thing. And we had to work very hard to get rid of it. And yet sulfur dioxide happens to be like the favorite choice of idiots all over the place. And they just don't know what they're asking for when they try to choose it. It isn't even, it is good. It is good at reflecting, and it is a natural thing that's out there, but that doesn't mean it's a good choice. Then there's, so forth. I'll let you go on and read the remaining ones yourselves. Then near the bottom of the document, I kind of wrap it up a little bit with, let's see, let me scroll
The moral
down.
dilemma. The moral dilemma.
Yeah, this is basically what I try to point out here is that, yeah, maybe we can do some good with this, but the first section, 5.1, is pretty obvious stuff. If we're reducing solar radiance, we're going to be reducing our photovoltaic and wind turbines and so forth are likely to be affected. Hydrologic power will be affected by changing precipitation patterns, and even a nuclear and so forth will also be affected, but less so, but still affected by changes in cooling water availability and things like that. But then when we look at the systemic level issues here, we really boil it down with, points 2, 3, and then finally 4 and 5. We get to, if you read all of that, you'll come to see that that the problems that are created by doing this are almost of the same scale as the original problem itself. And I have strongly stated right up at the top, and it's worth reiterating when you come down to the conclusion, is that the only way that we should ever engage in anything that is this risky, we must fund at least equally as well, if not much more so, to simply stop all of humanity from taking yet more sequestered, stored carbon and adding it to the atmosphere, what's called short cycle carbon, at least at the industrial scale. We just have to stop that. It's as important and more important, even if we were to pull off this damming effect, it's only temporary. The other problem is going to catch up with us. And the second thing is permanent carbon removal from the atmosphere. And I had intended to include a section about that, but the idea is it's already well proven and there have been tests already done, and we know this solution works. And the basic idea is to use, genuinely capture with as low carbon footprint as possible, as much atmospheric CO2 as we can manage to collect, compress it into a liquid form, and then squirt it into very specific types of rock where we already have wells drilled in the ground, and we can inject the CO2 there, and within 2 years or thereabouts, some huge fraction of that CO2 will be converted into forms of literal rock that are geologically stable and will from humanity's point of view, be completely permanent. I mean, you know, we're talking about millions of years time scale. So that's what we need to be doing, is removing the carbon. We got to stop adding the carbon from the atmosphere. We got to remove the carbon from the atmosphere. And if we're taking those seriously, then maybe we can buy a little bit of time by this dimming strategy. But either way, dimming is just a pretty, you know, weak system, weak strategy. And my concluding sentence, I'll conclude here with, only with a dual commitment can a dimming strategy, if ever employed, avoid becoming a fleeting Band-Aid on a sliced artery, a far too weak effort at addressing a problem that demands lasting solutions.
Okay,
And
thank you.
with that, I yield the floor. Thank you.